Hi guys, today's notes are on 8.4 and we're going to talk about series and summation notation. One thing to note is that we're slightly off in terms of section numbers with the textbook, so let me know if you need me to help you figure out where in the textbook we are working on. So let's do a quick review in these first 6 boxes at the top. Let's talk about recursive and explicit rules of sequences. So just a reminder that recursive rules start with a1 equals whatever your given number is for the first term. And then the next 2 terms are written exactly the same. So you have a sub n, which is any term, equals the previous term plus 5 or times 1/5, which is the same as divide by 5. Now please don't write your answer as divide by 5 here because we don't use this symbol in Algebra 2. What we want to do is write it as a fraction, and this still means divide by 5. So our first term here is 3, and then we're adding 5 each time. Right, so we're going to have 8, 13, and 18. And then this one, we start with 200, and then we're dividing by 5. So 20 divided by 5 is 4, plus an extra 0, divided by 5 is 8, and then 8 divided by 5 is just 8 over 5. If you wanted to do this without give me the next term without dividing by 5, because 8 divided by 5 is a little weird, what you're really doing is multiplying by 1/5. And so your next term will be 8 over 25. You just multiply your numerators and multiply your denominators. This is different than cross multiplying, which has to have an equal sign in the middle. Okay? So explicit rule of problem 1a. This one is an arithmetic. So I'm going to use this a of n equals a sub 1 plus d of n minus 1 formula. Now I'll plug in only a sub 1 and d. So I think in previous lessons we've been solving for different things because we didn't have a sub 1 or d. So right now, only plug in your first term and what you're changing by. We're not going to plug in n equals any number even though there's 4 terms, right? Because what we're trying to do is find a general rule or explicit rule. So we can multiply here. We get 3 plus 5n minus 5. And 3 minus 5 is a sub n equals 5n minus 2. Over here, we are doing the same thing. Please remember that explicit rules, I'll write this in because this was a big mistake or stuck point for people, only plug in a sub 1 and r or d, depending on your arithmetic or geometric, right? So since this one is geometric, we're going to use a sub n equals a sub 1 times r to the n minus 1. And so we have, first term is 200, my rate of multiplication is 1 over 5 to the n minus 1, and we're done. These last 2 are going to transition us into the next section. So if we are finding a sub 100, all that means that we now have n equals 100, and we're going to plug it in, okay? So we'll have a of 100 equals 5 times 100 minus 2. That's 500 minus 2, which is 498, and that's equal to the 100th term. The 8th term of this sequence, I know already that it's going to be a pretty small fraction because we're going to keep dividing and dividing by 5. But what we'll do is do a sub 8 equals 200 times 1/5 to the 8 minus 1. Now this is where it gets a little bit weird on your calculator, so I'm going to show you guys how to do fractions when your calculator is unable to do so. This will be 1 to the 5th power to the 7th. 1 over 5 to the 7th power. So if you actually type this in, and you do 1 divided by 5 to the 7th power, you're going to get a decimal value with e, which means that you have to move the decimal. But if we do math fraction, which is usually our solve fixer upper for fractions, this doesn't work. Okay, so this fraction has become so complicated that the calculator doesn't want to do it anymore. So how do you get an answer that's a fraction if your calculator won't? You can still do this. Would you guys agree that like this is 1/5 times itself 7 times, right? So this is the same as 200 times 1 to the 7th power over 5 to the 7th power. Okay. 1 times itself 7 times is just 1, so 200 times 1 over 5 to the 7th is 78125. Notice when I wrote this, the 200 and the 1 are lined up together on top. And so we're going to multiply across. Numerator and numerator is 200 times 1, all over 78125. Okay, technically you could probably try math fraction at this point, but we can also function without a calculator. I know I can divide both numbers by 5 because the top one is a multiple of 10 and the bottom has a 5 that it ends with. This will be 200 divided by 5 is 40, and this one I do need to do on the calculator. 15625, and I can do the same thing. Divide by 5 again. And so that'll be equal to 8 over 3125. I cannot divide by 5 again, and 8 can only be divided by 2 and 4, or 1, so we can't divide the bottom one by 2. So that means A of 8 equals 8 over 3,125. So hopefully you remember that anytime I'm giving you an n, you plug it in to find your value. So let's move on into our new topic. We've been talking about sequences so far, which are a list of numbers that follow a pattern. Notice that this ... means that this pattern continues indefinitely, which means forever. And a series is the sum of a sequence. So what is the sum of a sequence? Well, a sum means we're adding, and we're going to add the numbers together. So instead of doing 3, 5, 7, 9, we're going to add all of these numbers. Now, where is this useful? In the case of like as you become an adult, it might be helpful to see how a pattern grows and still add it up. So for instance, let's say I made $3, let's say $3,000 my first year of work, 5,000 my second, 7,000 my third, right? And how much money will I make if I work 20 years? So I could add 3 plus 5 plus 7 plus 9 plus, right? And add this up. We do hope that there's an easier way to do this, right? And that's what we'll be working towards by the end of today's class. Before we do that, we need to talk about what this symbol is, because these are the types of problems that we're going to see soon. This is called sigma notation, because this symbol is the Greek letter for S, or sigma. How do you draw this? It's actually quite straightforward. You draw a horizontal line across, you don't need to do the little hook, and then you do a greater symbol, and then a line across. Okay, so practice drawing that. Please make sure that you know line across, greater than, line across. So what does it mean? Well, there's always going to be a number underneath and a number on top. The number underneath tells you the first term that you're going to start adding together. The number on top tells you the last term. And then the rule here tells you what pattern we're going to add these 10 numbers of. Okay, so it's a shorthand notation. If I, as a teacher, were too lazy to say, find the sum of the first 10 terms of the sequence that follows explicit rule 5 plus 7n. So let's see what that means. Let's find the sum of this sigma notation. Now, notice n goes from 1 to 4. So that means we are going from the first to the fourth terms, or we're going to add them, I should say. Okay. So what we need to do right now is find the first 4 terms, right? So we have a sub 1, we need a sub 2, a sub 3, and a sub 4. Well, this would be nice if I gave you a pattern, but instead I give you an equation. So what can you do? You take your 1 and plug it in. to find a sub 1, right? So I'll take 2 plus 5 times 1, which is 2 plus 5 equals to 7. Okay, at this point I can do the same thing. 2 plus 5 times 2, right? And get 2 plus 10. And that's 12. But what if I don't want to actually plug in 3 and plug in 4? We also know that 5 is your difference. So if d equals to 5, that means I'm changing by 5 every time here. And so I know a sub 3 is 17. And a sub 4 is 22. And I can now add these terms up to get the sum of n equals 1, first term to fourth term, of 2 plus 5n, and that equals to 58. And I just have that memorized because I've done it a lot of times today already. Okay. And so we can do the same with any function, really, right? It doesn't have to be linear. This one is exponential, so I'm finding the first 3 terms. And so I can plug in 1, 2, and 3. 2 to the 1 power is 2, 2 squared is 4, and 2 cubed is 8. I'm going to add them all up. 2 plus 8 is easier, right? That's 10 plus 4 is 14. And that equals to sum of the first number to the third number of 2 to the n. Okay, so quick sidebar. Students always ask me, Ms. J, what do the parentheses mean? This 2 to the n power is the same as 2 to the n, and it's also the same as 2 to the n all inside the parentheses. And those are all the same. So today I'm going to be mixing the parentheses a little bit up for you so that you don't panic when you see something that looks slightly different, but it's mathematically the same. So what if we want to add more terms? We did 4 by hand here, but we had to calculate each one and add it up. And then over here we had calculated 3, but let's say I asked you for, like, I don't know, the next 200 months of your paycheck to add it up. We really have better things to do with our time, right? So this question actually was posed to a young child, Johann Carl Friedrich Gauss, in elementary school, and his teacher asked him to find the sum or add up all of the numbers from 1 to 100. And so, you know, some of the kids started chugging along, I'm sure, but Johann Gauss decided to find a faster way. And so what he did is he noticed that 1 plus 99 adds up to 100. And 2 plus 98 also adds up to 100. And 3 and 97 add up to another 100, right? So there's going to be half the number of hundreds as these 100 terms. So you're going to add up and we'll have, you know, up to 49 and 51. There's a 50 in the middle though, right? So what this comes out to be, and after finding this pattern, he decided to find, you know, a pattern that always works. So you'll see that he took half, because you're folding your numbers in half, right? You take half of the first term plus the last term. And so let's check to see if that works. If I took 100 numbers divided by 2 times the first term plus the last term, that equals to 5,550. Okay. Which, if we added this up, would be 49 hundreds, 50 hundred, which is 5,000, plus 50 right there. So I don't have a cool story for geometric series, I'm sorry. So these are the two formulas you're going to remember. You might also see me write this like this, with a1 on top, times 1 minus r to the n over 1 minus r. Now be really careful. This n is the only one that doesn't have an n minus 1 right now, right? Like an only exponent that doesn't have n minus 1. And so let's use our two equations. It's going to be very similar to when we were doing sequences, except now we're going to use the variable s instead of a of n. So any number, this is going to be s for series or s for sum. Okay. So here it tells you find the sum of each given series, show your work for full credit. The first question I always ask is arithmetic or geometric. And in this case, it's arithmetic because we're taking a number and adding by 3 over and over. So I'm going to write my formula up here. N divided by 2, a sub 1 plus, let me move that down a little because I want to tell you what we're going to do with those numbers. Sorry. So I'll do it down here. S of n equals n over 2 times a sub 1 plus a of n. Okay, so we're going to find our necessary variables, which means that we need to plug in n, a1, and a of n in order to find s, right, or our sum. So the first number we're going to plug in right here is n equals 50. Okay, so it's always the top number because we're adding up 50 numbers here. Well, a sub 1 is our first number, right? And sometimes we can see it from our equation, but other times we can't. So whatever equation I give you, you're always going to plug in n equals 1. And then for this one, you're going to plug in, for this problem, n is equal to 50, so we're going to plug in n equals 50. And when I say plug in, I'm talking about into the given equation. Okay. So I'm going to do that down here. So here's my plug-in, n equals 1 and n equals 50. So a sub 1 is 4 plus 3 parentheses 1 minus 1. Okay, let's keep going here. That's 4 plus 3 times 0, which is 4 plus 0, which is 4. Okay, so that's a sub 1. I know n is equal to 50. We know we have 4. We have s of 50 that we're looking for. Okay. And then let's find a of 50. That's our last term. So then we have 4 plus 3 times 50 minus 1. 4 plus 3 times 49, which is 4 plus 147, which is 151. Okay, I've done this problem a lot of times already today. So I'm going to take 151, plug it in here. And now we have a division problem and an addition problem that we can simplify to get 25 times 155 times 155, which is 3875. So S of 50 equals 3,875. Okay. Let's do example 4, and then I would say instead of doing these two problems, I would try the homework tonight instead. So this one, notice that there's exponents, so we know this is geometric, okay, because it's in the exponent. This number right here is your r, and 6 is my n. So I'm going to write my formula, S of n equals to a sub 1 times 1 minus r to the n power all over 1 minus r. Notice this time I didn't write parentheses, which is also okay. So we do need to plug in a sub 1, r, and n. R gets plugged in twice, right? So this one, r also. So a sub 1 we don't know yet. R is what we're multiplying by. That's my exponent base. N is 6, or your top number, right? The 6th term that we're adding up into. So we can take our function here, 4 times 3 to the k minus 1, and plug in 1. And it doesn't matter what my variable is. I can call this k or n or x or y, right? Just be sure that these two are the same. And so 1 minus 1 is 0. 3 to the 0 power means that I have no 3's, so I can cross them out. And a sub 1 equals to 4. So now I can plug in here 4 times 1 minus 3 to the 6th power. I did parentheses here because if there was a negative number, that negative does really matter. So what you're going to do is exponents first and subtract. order of operations. You cannot distribute until you take care of the exponents. So then I have 4 times 1 minus 729 over, I can make the line extend, negative 2. Okay, well if I have 1 positive and 729 negatives, I'm going to have more negatives by negative 728. You are welcome to use your calculator for that. And then this division problem can be, the 2 can be shifted over, and 4 divided by negative 2 is negative 2. Which means that S of 6 equals 2 times 7 is 14, and then 2 times 28 is 56. Okay, that concludes today's notes. Let me know in class if you have any questions.